चलिए दोस्तों शुरू करते हैं विदाउट वेस्टिंग ए टाइम. In this lab, we'll discuss about how to implement the segment routing flex algo. And in this lab, we'll configure the flex algo 200. So what is flex algo? Flex algo, we can say that it's in different, with the help of flex algo, we can run a IGP with the multiple algorithms, as flex algo means flexible algorithm. So operator can define the, or we can say configure the algorithm according to their needs. And with the help of this, we can provide different algo to the different customer according to a requirement. Like one customer looking for a low delay traffic, low delay path, and one customer looking for the high bandwidth path. So accordingly we can configure the nodes in that algo. We can provide to the service to our customers, and we can ignore the unreliable links. And one more benefit is with the help of flex elbow, we can send the customer traffic with the one label. We will see when we'll do the verification how we will be able to send the traffic with the one label with the help of flex elbow. Flex elbow will also help in achieving the network slicing. Network slicing means dividing a physical network into multiple logical networks. Like here we can see that we have in this physical networks is a part of four core routers, two provider edge router, and two core routers. And behind the provider edge routers, we have a customer network attached on the both side of the topology. So this physical network we have divided into the logical network. So this is the logical network. So we are saying PE1, P1, and PE2 are part of Flex 0 also and Flex 200. So these are the prefix-sid we are assigning. Prefix-sid 16,002, 233, 16,211, 16,244. These prefixes are part of Flex Algo 200. By default, all node will be the part of Flex Algo 0. So after once we configure the Flex Algo, after that we will configure the segment routing TE config on the PE1, and dynamic under the dynamic configuration, like we have earlier seen, we were doing the metric type TE when you define the segment routing TE. So under the dynamic, we will, instead of selecting the metric type TE or IGP, we will select the algorithm flex algo 200. And after that, once we'll implement the configuration, after we will do the verification, we will see while we send the traffic from to this prefix uh, triple two dot triple two dot triple two dot triple two in the VRF blue, which is part of customer VRF blue. This will take this path, as these three nodes are only part of flex algo 200. P2 is a part of only flex algo 0. This is not taking a participate in the flex algo 200. So let's jump to the configuration. So this is our first node. This is a P1 router. It's an head-end router. So let me quickly show the current config with respect to the ISIS. So this is the ISS core process we are running, and we have enabled the segment routing. This is the config related to the TE, and we have configured the prefix-sid in the flex algo 0 with the part of flex algo 0, and in the segment routing we are running the global box 16,000 17,000. Under the BGP, we are running a VPN v4 address family with the PE2 device, and we have configured the VRF, and loopback 100 is a part of VRF. We have this. So on this head-end router, we have to define the two things. First thing, we will enable the flex algo, and second thing, we enable the segment routing TE configuration as is in the head-end router. So let's jump for the flex algo configuration. In the flex algo, we need to define the router ISIS 4 as a part of flexible part of IGP only. So let's define flex-algo. So here we can define any algorithm number is range 128 to 255. So we're going with the 200. Okay. And after that, let's come to the side. Let's go to the interface. loopback 0, and after that we need to define a node seed for the flex-algo 200 on the loopback 0, like this thing in the prefix seed. This will, here we are defining the index, and earlier which we defined this was the flex-algo 0. Now for the flex-algo 200 we have to define it. So we'll go to the, let's go to the, where we are, let's go to the router ISS core, interface, address family, and we will say the prefix-sid algorithm 200 algo we are going to use. The absolute number input will put the 16,000 for this PE 233 will be our the nodes in prefix-sid for flex-algo 200. So one more thing is we seeing the message saying the routing ISS3 flex-algo node def. So there is no advertiser there, so it's disabled due to the missing definition, no FAD found. So one more thing, on one of the device, whichever the device taking the part of flex-algo 200, we need to define the configuration for the router. Let's go to the under the flex-algo context, and after we need to divide the advertiser definition. So this will advertise the flex-algo definition in the IGP domain. So this is the command required of the one of the node we can enable. So we have enabled on this node. So now we can see that message coming flex-algo for the 200 level 2 is enabled. Okay. Second, this is the thing we have done here. And second thing, we're going to the segment routing traffic engineering. And under the traffic engineering, we need to define a on-demand color. So this is the 100 extended community we will assign. We already assigned on the PE2 router for the triple two dot triple two dot triple two dot triple two prefix with the part of customer VRF blue, which is connected behind the PE2. And here we use the dynamic. Earlier we used the metric. So here we will use the SID algorithm. The last lab we have used this metric type, correct? We are using the T and IGP metric. Now we use the SID algorithm, specify the prefix SID algorithm. So our algorithm number is 200. This is the only configuration required with respect to PE add-on. Let's jump to the next node, P1 node, middle one node, provider one node. So here we are on our second node, middle one, provider one node. And this is also a part of flex-algo. Let me please show you the current config. So ISS, as is the core node, there is no BGP. BGP free core. ISS process core is running. This is the config related to the segment routing TE. This is enabling the segment routing. And this is the nodes in prefix-sid for the flex-algo 0. And index number, as we are using in all of the topology from the loopback 4th octet. And this is the segment routing global block we are using here. This is the configuration only. Now we need to enable a flex-algo. Router ISIS core. That we need flex-algo 200 we are going to use. And after that, on the interface, loopback 0, the address family IPv4, we need to define a node seed for the flex-algo 200, and absolute number we are using 6211. This is the only one we require. Let's jump to the last and final node, PE2 router. So this is your final node. Has only three nodes were the part of the flex-algo, PE1, P1, and PE2. Let me quickly show you the show run for this node. Router ISIS, and this is the core process is running. This is a command related to the segment routing PE, and this is for the segment routing MPLS enablement. This is the flex-algo 0 node seed. Again, same we're using the loopback fourth octet of loopback 0. So index number is 44 we're using. Here we are using the BGP and we are running the BGP VP on V4 with the PE1 device. This is the PE1 IP. In this neighbor, we have activated the address from the VPN V4. And here we are configuring the route policy blue. VRF is configured. Let me show you the route policy blue. What is showing? So RPL route policy blue. Under the route policy, we are saying destination is this. We have defined destination is here. This is the loop. And this triple two is the loopback 100 IP with a part of VRF blue. So we are saying definition is this. If destination is this, then set extended community color blue. Let's show this. Show it what is an extended community set. So here we are setting the 100 number, 100 community we are attaching, and same community, same number 100 we have used in the we have just configure on the in the segment routing tree configuration on the color on demand ODN. Correct. And show BGP feature, show BGP VPN V4 unicast advertise. So now we can see that either the two loopback configured in the VRF blue, this triple 200 where we are attaching this extended color community 100 number attaching, and while other prefix we are not attaching any community. This is going with the. Let's complete the flex-algo configuration on the PE2 node also. Here's our ISS 4 flex-algo 200 should flex 0 address from the PV4. With that we need to define fix algorithm 200 absolute. Here we put it on the 16 to 44. This is the node seed in the flex-algo. Done. Let's jump further. So now tunnel came up from the 40-second now, and here we can see that pended path is this, preference is taking the 200, is active, binding seed is dynamic, it's using in the constraint showing that it's using the prefix-sid algorithm, algo 200 is using valid, and this the I was talking about is using the single label only to deliver the traffic in algorithm 200, and that's it. So these are the things we have. There is no path from the PEC from the controller. It's showing the index. This is not interested only. This is the only as we have defined the local binding seed is 24003. This show ISS route under the flex algo 200. We can see that these are the nodes which are the part of flex algo 200. So this is the IP of provider 1 and this is the IP of PE2. So as flex-algo 200. I will do definition priority is this, and you can check local device. This is also this is a local. This is and we can check the route. Show route. Let's check show route 11.11.11.11 slash 32. Let's check for the ISS route. Show ISS 11 dot this is 44.44.44.44 slash 32. Okay. I'm taking the route for the PE2. Here we can see that. So this is the route for the PE2, and this is the prefix-sid belong to algo 0. Algo 0 prefix-sid is 16044. and prefix-sid index 244. So that is the 16244 which we have defined the absolute value. I show you the configuration now. Showing that this belong to algo 200 VI setting. Let's check the route if it's so this way for this local P 33 33 33.33. So I think here it shows the flex algo 0 on the same way. We can check for the P1 middle one router provider router only. Here we can also see that. So this is the prefix is 16211. So will be the algo 200 and prefix it 16011 that will belong to the, as you have seen the topology also we have two prefixes 16011 that is the part of flex algo. All devices by default part of flex algo 0 and we have configured flex algo 200. Let's do the trace route now also. Into the trace route triple two dot triple two dot triple two dot triple two. Sorry, we have to put the VRF first. So the part of VRF blue triple two dot triple two dot triple two dot triple two. Box is Java. Let's do the single trace for the another loop back. 200 dot 200 dot 200 and 200. So we can notice in the difference as we have this triple two dot prefix. On this prefix on the PE2 we have assigned the color community extended community 100 and that color community 100 is using the dynamic SID. We are assigning this segment routing PE policy. Whenever the color community is 100 dynamic, so compute path on the basis of SID algorithm 200. So in the trace route, we can notice that this is while tracing this prefix as it's using SID flex algo 200. So it's using a prefix-sid node SID of the algo 200 because in the 16244 this is the node SID for the PE2 node you define internal level is the VPN level. This is the VPN level. This is the node SID prefix-sid belong to flex algo 200. While we have not attached any community. If we see the route for the 200 also, so BGP VPN v4 unicast RD 1 colon 1 200 200 200 dot 200 slash 32. If we see, we don't have any community, any extended community color 100. So this is the region it's following the flex algo 0. As we can see that in the label, this using the prefix SID 16044. This is belong to this is the node set of flex algo 0. This is the node set of flex algo 244. While if you check the routes on the PE2 while advertises route, we have attached the extended community and that extended community is triggering the our SR policy. We can see that we have got the color 100. Once the color 100 is got, this segment routing PE policy got triggered and this sender use the to deliver the traffic for the triple two dot triple two dot triple two. These have used the seed algorithm 200. Let's check the database also. In the database also we'll see show ISS database even verbose. I do. We should be able to see that now we are getting the two ego. So let's see, let's go up. Various there, these are the extend link details are getting and they should be. This is here. Prefix-sid index 100 is a part of algo 0 and prefix-sid index 2000 is the algo 200. So you can see that this node is belong to two algo flex algo 0 and flex algo 200. If we check for the P2, as P2 we didn't configure any flex algo 200, so this will be part of only flex algo 0. So here should be there. Like here we can see that algorithm. This should be here only. Let's play we have seen the P1 metric after that, P2 metric. So there is no flex algo 200 here. We are seeing everything the only algorithm 0. Right? So there is no algorithm for the 200 as this node belong to only flex. Similar way we can check for the PE2. We should show this node also a part of 2 flex algo 0 and flex algo 200. Here we can see that this is the prefix-sid index and flag is set. This is the node sid for this algo 0. So this is the 16,044 as a block starting from a 16,000 to so run segment routing. If I do the global block, let me do this. Here we can see that the global block is defined 16,000 to 17,000. So according to this in this flex algo, this end flag is set. This is telling this is the node seed for inflex algo. For this node P to 16,044 and for the algorithm 200 prefix it node seed with the 16,244. As we will check earlier also again we are checking the route also we can check what are the routes we are getting in this flex algo. So these are the routes we are getting. So these nodes are only belong to flex algo. Thank you.